Okay, so 7.3 has two different learning targets. We are going to tackle these actually in a different order than what is listed up here. It's the same as basically what I did when I printed your note packet is I flipped around the front and the back. So we're going to first work with negative exponents because hopefully, after I know those were some challenge problems, after those challenge problems, we may want to boost up our confidence a little bit. I know we all know how to work with negative exponents, so we're just going to formalize it in our notes a little bit. Then we're going to move on and rationalize radical expressions, and I have 6 examples that I'd like us to do rationalizing. And then for your homework assignment, you have 2, the 7.3 worksheet, and then there's a 7.1 to 7.3 review worksheet right after. I know, practice, practice, practice. So let's talk about negative exponents, right? We know if we have a negative exponent in our numerator, it'll move to the denominator and become positive, or vice versa. If it's in the denominator, it moves to the numerator and becomes positive. So let's look at some kind of low-level examples, right? I think we know how to do these. I have 5 to the negative 2, so it becomes 1 over 5 squared, which is 1 over 25. Next example, 2 to the negative 3 becomes 1 over 2 cubed, which is 1 over 8. Our next one, our negative exponent happens to be in the denominator, so it moves up. 3 cubed, 27. And then our last example moves up to the numerator as well. 4 squared, 16. Please just holler at me if I start going too fast. I know that we've been doing a lot of work with negative exponents already, so I figured we could kind of fly through some of these examples. All right, let's move on to some problems with variables in them. I have x to the negative 3, so it becomes 1 over x cubed. No more negative exponent. This example here, I have the combination of x times y to the negative 2. So this is going to, the whole thing's going to move down. I have xy squared, or, and we have to make sure we kind of know our rules to be able to see, okay, which answer choice is the correct one. I could write it as 1 over x squared, y squared. Both of those mean the same thing. It just depends on kind of the problem that you're working with, what they're going to expand it out as. All right, and letter C, what is the only thing attached to the negative exponent? 1. So that is the only thing that moves. I know you may want to move the 2. The 2 is just a coefficient. It does not come along for the ride. So I get xy, y cubed over 2. And what is the final exponent of my y? 4, right? I've got to combine these together, and since I'm multiplying, keep the base, add your exponents. That is my final answer. Same thing with letter D. I'm just going to move the y up to my numerator. And normally, right, we like to write these things in alphabetical order. You know, I'll be very flexible with that if you don't write them in alphabetical order. But we get x, y cubed, z. Questions on those so far? Told you we'd kind of be flying through these. All right, in example 6, right, we're starting to put a lot of different variables in there. There's a couple different approaches that you have. The first is you can get rid of the negative exponents right away. You can say, okay, I'm going to move this up, and I'm going to move this down. So I get 4 x to the 7th over x cubed. Right? Some people don't like working with negative exponents at all, and so they want to put it in this form and then say, okay, now that I see I'm dividing, I'm going to keep the base and subtract my exponents. Your other option is just to do the integer math as it is right at the beginning of your problem. You can just say negative 3 minus negative 7. Whenever you do that division rule or that power rule or whatever the case may be, you always end up in the numerator. So whatever approach you like to take, know that when you do that division rule and you subtract your exponents, you wind back up in the numerator. So if you get a negative exponent after you do that, you might have to move it back down. All right, looking at our z's and our y's here. I'm just going to go right to our exponent rule, right? With my z's, because I can only combine those that have like bases, I keep the base and I'm going to subtract my exponents. 2 minus negative 3, 5. I'm going to keep my base of the y, negative 1 minus negative 2, 1. Same thing over here. Well, right away I see I can really just cancel those y's out, right? If I have a y in my numerator and a y in my denominator, those cancel out. I get negative 2 minus 1. So I get 3z to the negative 3. And that's why I say sometimes when you run that division rule, you might have that extra step of then moving the thing with the negative exponent down to the denominator. So I get 3 over z cubed. Okay, last couple of examples on negative exponents here. I'm raising a power to a power, right? So I'm trying to go through all of our different rules that we have for exponents, just throwing in some negative ones. I need to raise the negative 3 to the power of 2, and then also everything else. And when I raise a power to a power, I multiply. Now I have to simplify. Negative 3 squared, 9. I need to move my x to the negative 2. That needs to go down to the denominator. It's the only thing that has a negative exponent. So my final answer is 9y to the 4th over x squared. All right, try letter B on your own. You're multiplying. So you've got to multiply your numbers, but you've also got to remember your power rule. Keep the base, add your exponents. No, there's no plus sign. The FOILing only happens if you've got pluses and minuses. You're just multiplying. Yep, you're just multiplying. Keep the base, add your exponents. Multiply. You're not raising a power to another power. Yep, don't move that negative 10. That's the only thing. All right, I have to multiply these, so I get negative 10, add my exponents, x to the negative 5th, y cubed. I then move the x to the 5th down to the denominator. And I know, right, we see a negative number, right, and it's going to trick us into thinking that the negative 10 needs to move. But the only thing that moves around is that negative exponent. Out of one of your homework assignments, the 7.3 worksheet, the bulk of the questions are these types of questions. So I know you're going to be able to fly through them once you practice and get the hang of it. So go ahead and move on to the next page in your notes. There are some warm-up questions at the top. We are Oh, sorry, you already have the warm-up questions. We are skipping those warm-up questions if I didn't say that because we already have done a number of warm-up questions. So we are going to do what is called rationalizing the denominator. Does anybody remember a previous time we talked about rationalizing a denominator?
Was it when we had to take the square root out of the bottom?
Woohoo! That's it, Graydon. That's exactly right. For those of you following along, right? I'm not allowed to have a square root in the denominator. So what did we have to do when we got something like this? Multiply, right? We had to figure out the perfect number 1 to multiply by, and that would then take the radical out of our denominator. Well, now, when we have an nth root in the denominator, in this case a 9th root, we have a radical down here. It's not a square root, right? We have a 9th root. You're not allowed to have any kind of radical in your denominator. So what we do is we need to make the denominator a perfect nth root. So this was our kind of like, this was probably what? A long unit ago, maybe unit 2, right? It's been a long time. So what I want to do is I want to figure out what is the perfect number 1. It can only be the number 1. I'm only allowed to multiply by the number 1, or I change the problem. In order to get 5 to the first power. I want a whole number there. I want 5 to the first power. Sarah?
9 halves.
Ooh, okay. Let's think about this for a second. So you're saying if I have 5 to the 9 halves, if I am multiplying, what do I do with my exponents?
Or no, add them.
I add them.
Oh, yeah.
Are these going to add to 1?
No.
Not a bad idea, right? So, what do I need to add to 2 ninths to get to 1? 7 ninths. So I multiply by 5 to the 7 ninths over 5 to the 7 ninths. And yes, I know, very ugly. Very, very ugly. So I have 3 squared, which is just 9. And yes, that is your final answer. It is very ugly. Think of this as, as you're solving or simplifying all these other big expressions. If you end up having a radical in the denominator, this is like the icing on the cake, the last step that you take to really finish that problem. You end up with very ugly answers, but that's okay. That's what we're looking for. So we have 4 or 5 more examples to go through with this. So if this hasn't clicked yet, don't worry. We're going to do a couple more examples. Hopefully it will. So here I have 2 to the 5th over 3 to the 4/3. So I see right away, right? I have different bases. I'm not going to be able to combine these. This is just the number 32. I want to multiply by some number 1 to get up, and in this case, it can't be to 3 to the 1. I'm already at 3 to the 1 1/3. I've already gone over the number 1. So I need to go to the next whole number up, which is the number 2. I know, so you're saying, why can't we subtract, right? Why can't we just subtract 1/3 from here? The problem is, if I do that, I'm going to end up with a negative in my numerator. And where am I going to have to move that? Back to my denominator, and I'm back to square 1, okay? It's not a bad idea. It just, unfortunately, when it comes to rationalizing radicals, it's not going to work. So I always have to think to myself, okay, right now, I'm at 1 1/3. I need to go up to the next whole number. So how many thirds do I need to add to get up to 2? 2/3. So 3 to the 2/3 power. My numerator then becomes our ugly answer of 32 times 3 to the 2/3. And my denominator is 3 squared, or you can write that as 9. But I want to show it this way so that you see why we're getting up, why we would go up to that number 2. Questions?
Would you want us to simplify that? Right?
Sure. You don't have, you can, we can. Right, the big leap though is knowing that we need to get to this place. Then yes, we'll do all the simplifying and if we can cross cancel or anything like that. All right, let's look at a third example. So we were just doing some examples with fractional exponents. So I want to do a couple of examples just doing it with radicals. The first thing I do is I'm going to break apart that fraction because the thing that I'm trying to get rid of is the radical in the denominator, right? The radical in the numerator can just stick around for a while. It can be as ugly as it needs to be. So I'm trying to get to a perfect fifth number. Let's write down some fifths. 1 to the 5th is 1. 2 to the 5th, 32. Can I multiply 4 by something to get to 32? What? 8. So here is that number 1 that I'm multiplying by. So in my numerator, I get the 5th root of 24. My denominator, 5th root of 32, which can be simplified down to just the number 2. Right, because that was the goal. All I wanted to do was be able to get rid of that radical from the denominator. Let's look at a couple more examples. Doing great. Lots of numbers and letters in your head probably right now. All right, let's do one with a variable. I have the 4th root of 2 over the 4th root of x cubed. Based on my index number, how many x's do I need to be able to take one out? 4. How many x's do I have now? How many more do I need? That's right, I need 1 more x. So the 4th root of x over the 4th root of x. My numerator, I'm going to multiply those two things, right? I have the same index, so I can multiply those two together. And then down here, I get the 4th root of x to the 4th, which is just x. All right, last one together, because I can see I'm losing some people. We've got the 4th root of 16 over the 4th root of x to the 14th power. The 4th root of 16, that's just 2, so we can simplify that down. I currently have 14 x's under my radical. What's the next number up from 14 that is divisible by 4? 16. So how many more x's do I need? 2. So I get 2 over 4th root of x to the 16th, which is just x to the 4th. No more x's under a radical, no more radical in the denominator, and that's all I was going for. All right, in order to get started on your homework, because I do want to check in with each and every one of you to make sure we got this, or at least we kind of understand the concept, you need to tell me, what do I need to multiply? You don't even need to simplify this one. Just tell me what is the number one here that I need to multiply by in order to get rid of this radical in the denominator. Coming.